Assalamu alaikum. My name is Mohamed ElSaman, and today I'll be talking about the design of footings and foundations. So I have already figured that I can group my footings for 5 categories over here. So as shown here in the figure, I have grouped my C9, C10, C15, C16, C21, C22. Those are the middle will be as group 1, and the exterior will be C3, C4, C27, C28. Those will be the HCOM, that's group 2. And group 3 will be the combined footing as C1 and C2. This will be one combined footing. C7, C8, second combined footing. So this will be here as group 3. And this one will be also mirror for that one. So C5 and C6, that's a combined footing. So first, for the design, I assume the soil weight is 16 kilonewton per meter cube, and for footing thickness is 600 millimeter. The cover is 100 millimeter, and the soil pressure we assumed it as 750 kilonewton per meter square, as I asked an site engineer working here in Qatar in a Muslal site, and he gave me those number for the soil. And after that, the number for the dimension for the column is 0.3 by 0.3, which is BC1 and BC2. And after that, I just calculated the D, which is T minus C, and then the weight of soil and the weight of foundation of the footing, and then QE, which is QU minus gamma concrete by T minus gamma soil by T. And then I found B by L to find 3.17 meters square, which is to find the B and L, which is 1.78. So it's 1.8 to be chosen as rounded. And then I found the QU design, the B ultimate for the column, and multiplied it by 5 since we have 5 multi-stories. And then I calculated BS1. Then I calculated the shear, VU1. And then I went for D1. And used that formula, and I have found that it's 215 millimeter, so it's less than D, so it's safe for one-way shear. And after that, I calculated B node and VU2. To calculate D2, I used that equation, and I found 365 millimeter, which is less than 500 millimeter, so it's safe for two-way shear also. So after that, I just calculated the MU. The MU we just calculated by using this equation, QU design multiplied by P1 square divided by 2, and then I found Rn, and using this equation, after that I found the rho, and using the rho, it's less than 0.003, so I have to take rho minimum, and then I just get the area of steel by rho BD, and using these tables, I have found the area of steel as 6519. So this will be using for the isolated footings. And group 2 will be exactly the same, as we don't have much different in PU for the columns in the exterior and in the middle. So after that, I went for group 3 to calculate the combined footings. So the same steps is almost to find the footing, column, and D, and weight of soil and weight of footing, and then QE. The only difference that B by L to get the dimension of the footing, will just use this equation P1 plus P2 divided by a QE. So after using this equation, I have found it 4.88, and to calculate X, which is the dimension of the combined footing. So it's P2 by X2 divided by P1 plus P2. I found 4.4 meter. So L will be double this. So 2 multiply 4.4, it will be 8.8. So for QU design, PU plus PU2 divided by B by L, I found 180 kilonewton per meter square. So after that, this shows how I calculated B1 and BU2, and here is the distance between them. And the same steps as we used in isolated footing. And then here is the area of steel. I found that is 7529 by using this area and using the table of steel. And those are the foundation detailing. And It's all the same dimension for combined and for the isolated. Here is for flat plate and for flat slab and solid slab. And that's it. Thank you. And we would like to thank Dr. Osama Abeid for teaching us all of this. And we have really enjoyed the course using the new system, which is course project-based learning. And thank you very much.